Hey everyone, welcome back to Biological Imaging. Today I'm going to show you a few more features of the compound light microscope. I'm going to talk about the EOS utility software, and I'm going to show you how to put a scale bar on your scientific images. To start, I would like everyone to first put on a pair of gloves while they're in the laboratory, and I would like you to clean off the eyepieces with Windex and a paper towel. Please don't spray the Windex on the machine itself, but rather on the paper towel. And then I'd like you to clean both the glass of the eyepiece and then the outside collar. Okay. Then we have to power up the computer, which I've already done by pressing the power button on the back side of the lower left-hand corner of the monitor. Once the computer's on, we need to log in, and the ID and password is the same, bioimaging for each, all lowercase, all one word. Then we need to turn on the microscope, and the power button is on the left-hand side in the back. It's a toggle button, and if you toggle the switch up, it turns the microscope on, and you can see some light coming from the light bulb in the base of the microscope. Then we have to put in our SD card into the camera, and first you should make sure that the camera's off. You never want to put the SD card in the camera while it's powered up. The camera is indeed off. I'm going to lift up on the door and then pull it open on the hinge, and we want to put the SD card in label side up into the camera. Then we lift the door back up and pop it in place by pressing down gently. Now we can turn the camera on, and the power button for the camera is on the top of the camera, or in this configuration on the back side, and now the camera is on. I then need to power up the EOS utility software. So on a Mac, I'm going to left click the mouse onto the desktop so that I've selected the desktop. Then I'm going to press Command F to open the Finder, and then type in EOS space utility. Now I can see the different versions of the EOS utility that are on this particular Mac, and I'm going to select EOS Utility 2 because that's the version that works with these cameras that we have, which are Canon Rebels. So I double click on the software, and this window opens up, and the first three listings are grayed out, and the one that we want is camera settings, remote shooting, which is not clickable at this point. It's because the computer and the camera aren't communicating yet for some reason through this orange USB cable. So I'm going to try to fix this problem by turning the camera off and then back on. That shut down the EOS utility as it did the last time. So I'm going to double click on the utility again, and now all of the buttons are clickable. They're lit, and I'm going to click Camera Settings, Remote Shoot. Now my control panel for the EOS utility has come up, and I'm going to close the Finder. In the utility, I first want to make a new folder for today's images, so I'm going to come over here to this file icon and double click it. I'm going to select Browse. I'm going to select Desktop because I want my folder to be on the desktop. I'm going to select New Folder. I'm going to call it Joe's Images 2. I'm going to create the folder. I'm going to open the folder, and then I'm going to select OK for the preferences. Now you can see that our images are being saved to Joe's Images 2, and if I move the control panel over, here is the folder that we just created, Joe's Images 2. Okay. I also want to make sure that the ISO setting is set at 100, which it is. If it were something other than 100, I would left click with the mouse, and then I can move up or down to select 100. Since it's already selected, we're fine there. I also want to make sure that the camera is set at aperture priority, which is what this AV stands for. You can't change that from the control panel. There's a knob on the camera that controls that particular mode. So if it wasn't on AV, I would have to go to the camera and turn the dial until we were set in aperture priority. But we're okay here. We're also saving each image as a RAW file, which is the highest quality image that the camera can produce, as well as a very large JPEG file. So each image that we take is going to be saved in 2 different file formats. We're also saving both of those images to either the file folder that we just created on the desktop of the computer and on the SD card that we placed in the camera. So we're creating 2 images, a RAW and a large JPEG, and we're saving a copy to the folder on the desktop and to the SD card. I also want to make sure that this is set on 0. This is aperture priority, and I'm going to talk about that in a moment, but this should be set on 0, and if it's not, you can move these arrows until this lines up as 0 on exposure compensation. Now we can open up the live view window, and here we are. You can see that there's some light coming through the objective into the camera, and I want to set this up so that this light source is centered. What we're trying to do is something called Kohler illumination, and it's a way of aligning the scope such that the condenser lens is focusing the light from the light bulb onto the sample. So the condenser lens is a lens below the microscope stage, pointing up towards the microscope objective, and that's receiving light from the light bulb in this field diaphragm. So the light's coming out here, going through the condenser lens, and will shine light, focus light on the sample itself, and I'm going to show you how to do that. I have a slide here that I picked out of the slide box that I wanted to check out. It's called Muscle Types, and it looks pretty cool from a bird's eye view. I'm going to place it on the microscope stage by pulling back this spring lever and setting the slide on the stage and sliding it in such that the slide is up against the right-hand side of the slide holder and against the back edge as well. Then I can release this spring lever, which will hold the glass slide in place. We can move the slide and the slide holder with this articulating arm that has 2 turnable knobs on it. The top one moves the slide towards me or away from me, and the other moves the slide left and right. So you can maneuver the slide on the stage and find your sample. I'm first going to try to focus my sample with the focus, with the coarse and fine focus knob. It's a little difficult because the light isn't centered correctly. So to achieve Kohler illumination, I'm first going to move the objective from the 5x objective to the 10x objective. Kohler has a much more profound effect on the higher magnification objectives than the 5x. So I'm going to start with the 10. Then I'm going to decrease the aperture of the field diaphragm, which is down here just above the light bulb, and I'm going to turn it counterclockwise to make the aperture of the field diaphragm smaller. So now you can see it's towards the top edge of the live view window. Now I'm going to try to center the condenser lens using these 2 adjustment knobs. So I'm first going to try the right knob, and that starts to center it a little bit. I'm going to close the field diaphragm a little bit more, And again, I'm going to try to focus my sample a little bit here. Okay. I'm also going to turn down the light source power a little bit, which is controlled on the right-hand side of the microscope with a knob that's behind the focus knob. And I'm going to try to center the light again. Now I'm going to try to focus the condenser lens by turning this knob here, which is in front of and above the focus knob for the sample. So this is to focus the condenser lens that's below the sample. So I'm bringing it up and it's condensing the light. And now I'm going to readjust the condenser lens so it's a little bit more centered. Whoops, it's a little tricky here. Okay, now I'm going to focus the condenser lens again until the edges of the field diaphragm become sharp. And I'm going to again turn down the light source a little bit so it's not so bright. And try to center this again. Now if I open up the field diaphragm, I can see my sample. I'm going to focus the sample using the focus knob. I'm going to focus the condenser to make the edges of the field diaphragm as sharp as I can make them. Something like that. And then I'm going to decrease this so I can see the entire opening of the field diaphragm and then recenter this to the best of my ability. Okay, so now I'm going to refocus the sample. So now my sample is in focus. My edges of the field diaphragm are in focus, and the light is centered in the middle of the window, in the middle of the live view window. I'll tweak it a little bit here. Something like that. Now I'm going to open the field diaphragm so that the light fills the entire live view window, but I'm not going to open it up all the way. I'm just going to open it up enough so that the live view window is completely filled with light. And now you can see my sample. The condenser lens is focusing the light from the light bulb onto my sample, and my objective is focused on the piece of tissue, or this particular part of the tissue. Now you can see that the muscle is stained red, but there's some area where there's no tissue here, which looks yellow. It's because the white balance is off. So I'm first going to go up to my shutter, and I notice that my shutter speed is really slow. So it might work for this piece of tissue because this tissue is stained, it's fixed, and it's been mounted to the slide. But later in the course, we're going to look at live organisms, live marine organisms, that are going to be moving around. So we need a much faster shutter speed than this here. So I'm going to increase the amount of light by increasing the power on the light bulb, which again is on the back right side of the microscope, and there are 3 finger wells to help you turn it, and I'm turning it clockwise, which is adding power to the light bulb. I'm going to mouse over, and my shutter speed is 1/60. That's a little better, but I'm going to keep going. That's still kind of slow for me, and I'm going to see if I can set it here at 1/125th of a second. So that's a fairly fast shutter speed. Something like 1/100 to 1/400 should be fast enough to stop motion blur. Now, instead of this white portion being yellow, it's a little bit blue. And that's because if you change the power of the light bulb, either increasing it or decreasing it, the color of the light bulb changes. So we need to correct this by doing a custom white balance. And we need to open this door here. There's 3 little hash marks. And if you click on that once with your mouse, it opens up this white balance menu. And I want to make sure that this box is checked, apply to shot images, because we want our white balance to be applied to all of those images. And now we need to change the white balance so that it's correct. So I click on the eyedropper. This window comes up that says custom, which is what we want to do. So I'm going to just click OK. And now I'm going to move the sample over to find a part of the microscope slide that doesn't have any sample on it, like this here, and I'm going to click on this part, and that took out some of the blue. Now I have to unclick the eyedropper, otherwise it remains active, and I like to close the door just to keep my desktop neat and tidy. Now I can put the sample back in. I like this part here. I'm going to refocus. If you want to use this zoom tool, you can either grab it by putting your cursor inside the box and holding down with a left click. I'm holding it down, and then I could pick an area like this and double click inside the box, and up pops the zoom window. Now you can use this box to try to focus your sample a little bit better. Something like that. Now when we take the photograph, we are not taking the zoom view image, we're taking the live view image. So I'm just going to close the zoom box now that we've refocused, and this is the image that we're going to take. And I'm going to take it by going over to the shutter button. I'm going to recheck my shutter speed at 1/100 with an ISO of 100, and that looks good, and I'm going to take the photograph. This is our final image, and we always want to look at the final image to make sure that the composition is right, that the white balance looks correct, and that the exposure is where you want it to be. So you can this live view is only a tool to help you focus and help you compose the image that you want. So you need to take a look at your final image to know exactly what was captured when you pushed the button. And I would say that the real image is a little bit darker and a little bit more contrasty than this live view image. This image is 9957. It's a CR2, which is Camera Raw 2 file. So this is the raw file. But if we go to our folder, which is Joe's Images 2, and I open the folder, you can see that there's the CR2 image and the JPEG image stored in our folder. And as I mentioned, it's also being stored on the card on the camera. We need the card on the camera to shoot video. To shoot stills, you can save your work either to a folder on the desktop or on the hard drive, or you could store it on a thumb drive or an external hard drive. But for videos, we have to shoot directly to the card because the information can't be carried fast enough through the USB cord to save it on the computer itself. Now, if I want to move up from the 10x objective to the 20x objective, I can turn the objective turret so that the 20x objective is now in place. The 20x objective has a green stripe on it. And now I can focus for the 20x objective. Okay, something like that. And now if I go up to the mouse, if I mouse up to the shutter, I only have a shutter speed of 1/40, which is too slow. As you go up in magnification, you need more light. So what I'm going to do is I'm going to increase the power on the light bulb again with the knob on the back right side of the microscope. And if I mouse over the shutter, I can see that my shutter speed is increasing as I increase the light. 1/100, and now my power is max. I maxed out the power on the light bulb. So I can only shoot this at 1/100, but that's acceptable. Also, when I increased the power to the light bulb, again, it made the areas that should be white tinted a little bit blue. It's a little cooler. So I'm going to redo my white balance, my custom white balance, by clicking on, opening the window and clicking on the eyedropper. And I could move the slide again off so that there's no tissue and I'm just looking at the glass, but this part here doesn't have any tissue on it. So I'm going to use that as my reference point. And I clicked on it, and that took the blue out of the image. I'm going to unclick the eyedropper and then close the window again. And now I can take my photograph at 20x. Now if I want to move to 40x, I can swing the 20 out of the way and move the 40x objective in place, which has a blue stripe on it, and then focus the 40x objective. Something like that. Now, if I mouse over the shutter, my shutter speed is 1/30, which again is now too slow. But I've maxed out the power on the light bulb, so I can't increase the light source on the microscope. The only thing I can do now is increase the ISO, which is the sensitivity of the sensor. So if I double click on the ISO, this window pops up and I can press the arrow and make the ISO 200, which is twice as sensitive. So it's going to increase it's going to double our exposure. But the camera is trying to keep the exposure the same because it's guessing what it thinks the exposure should be. So if I mouse over the shutter, when I change the ISO from 100 to 200, that makes the sensor twice as sensitive, and the camera set the shutter speed from 1/30 to 1/60. So the sensor is twice as sensitive, but the shutter speed now is twice as fast, so we'll get the exact same exposure. If I double click here and I move up to 400, that's twice as much exposure as ISO 200 and 4 times as much exposure as ISO 100. And when I mouse over the shutter, my shutter speed now is roughly twice the 1/60. It's 1 over, of course, twice as fast would be 1/120. This is a typical shutter speed, 1/125, so the camera chose to use that particular shutter speed. Now I can take the photograph at the 40x magnification. There we go. Let's go back down to the 10x. This is the 10x exposure again. Now my ISO is at 400. I don't want that. My shutter speed is 1/1250, so that's really fast. So instead of using that shutter speed, I'm going to double click on the ISO and bring us back down to ISO of 100. And now when I mouse over the shutter, I'm still at 1/320, so that's a little higher than I would like. So I'm going to turn down the power on the light bulb now. That's 1/250, 1/200. 1 over 160, 1 over 125, right there. Now I'm going to focus my sample for the 10x objective. Something like that. I'll move over to get a different shot than the one we took previously. Let's say something like this. I'm going to refocus, and I'm going to check the white balance again because we turned down the power on the light bulb. So every time we touch the power on the bulb, we need to recheck the white balance. So my white balance is okay. I'm going to unclick the eyedropper and I'm going to shut the window. My ISO is at 100, which is what I want. And my shutter speed is 1 over 125, which is also what I want. So I can take my photograph now. So this image looks fine to me. It might be a little bit underexposed for my taste. So if I want to change exposure, since we're in an automatic mode for exposure, we have to kind of trick the camera. And the way we do that is by using this tool here, which is called exposure compensation. So we double click on this and this window comes up and we're at 0. We set it at 0 when we started our microscopy this morning. And if I move towards +1, I'm adding light or adding more exposure. And if I move towards the -1 or -2, I'm decreasing exposure. If you go from 0 to 1, that's a full f-stop, so that is twice as much light as at 0. But Canon allows you to increase the exposure in 1/3 increments. So from 0 to this dot here is 1/3 of a stop. From 0 to this dot is 2/3 of a stop, and from 0 to +1 is a full stop, twice as much light. I'm just going to bring it up to +1 just to exaggerate the exposure issue, and now I'm going to take a photograph. And you'll see now this is too much light. It's overexposed. So I'm going to be a little less aggressive, and I'm just going to use 1/3 of a stop higher than the 0 setting and take my photograph. So that looks good to me. That's a nice exposure. Okay, now I'm going to show you how to make a scale bar on your image. And in order to do that, you need to use something called a micrometer slide, which is a small ruler that's been printed on the glass slide itself. And I'm going to remove the sample that's on the stage, and I'm going to replace it by the micrometer slide by moving the spring lever over and placing the slide into the holder and then returning the lever to hold the slide in place. Now, in terms of our muscle slide, there are 3 things that I want to record in my laboratory notebook. I want to record what the sample is, and this again is muscle types. I want to record the microscope objective that was used to take the photograph. In this case, it was the 10x objective for this last photograph. And I want to record the number of the image, which in this case is 9962. And I really want to do that for every single image that I've photographed. So I should have an image number for each image, and I should have the tissue type that I was imaging, the sample that I was imaging, the name of it, and the objective used to take that particular picture. So all of that is going to be recorded in my notebook. In order to use the micrometer bar, we have to find the little ruler on the slide, and that's a little tricky. I'm going to reduce the objective to 5x because it's always easiest to find things at the very lowest magnification. Here we go. Here's the scale bar, or the micrometer bar, rather. I'm sorry. And I'm going to move the 10x back in place because I need to photograph the micrometer bar and the slide using the same microscope objective in order to draw my scale bar. So it's a little blurry, so I'm going to focus now with the 10x objective. And then I can straighten out the micrometer by turning the camera just a little bit. And then I'm going to find the end of the ruler of the micrometer, which is right here. And I'm going to try to line up the right edge of the micrometer with the edge of the zoom view window. Whoops, let's see here. Okay, just like that, perfect. Let's see here. Okay, so this 1.0 is 1 millimeter, and the 0.5 is 0.5 millimeters. So that means this 1 millimeter distance from 0 out here to 1.0 has been divided in 10 increments. 1, 2, 3, 4, 5, and then another 5 out to 1.0, which means that this distance between this line and this line is 0.1 millimeters, which is 100 microns, or micrometers. Okay, so now I'm going to take a photograph of this image. So the distance from one edge of the live view window to the other edge of the live view window is 1.123 millimeters. So it's 1.3 millimeters wide. So let me take my photograph of the micrometer, and now I have both my micrometer image as well as my muscle image, both photographed using the 10x microscope objective. Now I can close the EOS utility. And I can open up my folder, Joe's Images 2, and this is my micrometer image, the CR2, the camera raw file of the micrometer image, and I'm going to drop that into Photoshop. Okay, I'm going to say open. And I'm also going to open the muscle image taken with the 10x objective, which is the image right before my micrometer image. So 9963 was my micrometer image, 9962 was my 10x muscle image. And I'm going to drop that one into Photoshop as well. And now I have my two photographs. So if I click here, I have my micrometer image, and if I click here, I have my muscle image, both taken with the 10x objective. Now I can go up to Window and go to Arrange, and then I want to place these two images side by side. So I want it to be 2 up vertical. And I have my two images. Now, the images are too big at this size. I mean, the whole image isn't fitting on the screen, so I'm going to press Command and the minus button, which is the one just right of the number 0 on the keyboard. And I'm going to hit it once, and then I'm going to hit it twice. And then I'm going to click on the micrometer image, Command, minus, minus. So now I have my two images side by side, both at the same size, taken with the same microscope objective. So to make my micrometer, my scale bar, I need to first go to the line tool, which is usually the rectangle tool. So that's the default, is the rectangle tool. And you select the rectangle tool by left clicking and going to the line tool. Then I need to change the weight, which is the thickness of the line, before I draw the line. If I draw the line, I can't change it after the fact. So I'm going to try 50 pixels as a starting point, and then I make sure that my line is clicked, and then I start in the middle of one line, and I could make it 0.1 millimeter or 100 microns wide, but I'm going to make a longer scale bar. I'm going to make it 0.2 millimeters long, or 200 micrometers. And you'll notice that when I pull the line out, I can move it to any angle, but if I want it to be perfectly horizontal, after I draw part of the line, you just hit the Shift key and it makes it perfectly horizontal. So I'm going to stretch this out to be 0.2 millimeters or 200 microns wide. Now, I want to go to Layers, which is right here. And these are the two layers for my micrometer slide. If I press this layer, this eyeball, it removes the image of the micron bar. And if I click this one, it removes my scale bar. But I want my scale bar to be up, and I'm just going to grab the scale bar and I'm going to drag that layer over to my image and drop it on the image of the muscle. That places the scale bar onto my muscle image, and then if I select this move tool, I can now grab the scale bar and move it to wherever I want in the image. Most of the time people draw the scale bar in the lower right hand corner. Unless it doesn't show up very well, then you could put it somewhere else. Maybe we'll put this one over here. And so there's my 0.2 millimeter scale bar, and then I want to label it. So I'm going to label it, instead of in millimeters, I'm going to use microns. So this is 200 microns. Micron, 200 microns, or micrometers. Or I could use the symbol for micrometers. Any of those are fine. I'll just spell it here. I don't know, that looks like it's at an angle. Maybe I didn't draw it correctly. Let me try again. I'll draw another one. Maybe I didn't have the shift down correctly. So I set my cursor in the middle of one line. I stretch it out microns, and then I can hit the Shift key, and that should make it perfectly horizontal. Yeah, this one looks out. So now we can drag this one over. What do I have to do here? Click the move bar, and I'm just going to delete that one, and then I'm going to put this one in its place. That's much better. And that's how you make your scale bar. And then I can get rid of these if I want to. And let's see, click on the shape. and get rid of those. And I can use the scale bar now to create, this micrometer image that was shot with a 10x objective for any image that I've captured with the 10x objective. So I'm going to go up here to Save As, and I'm going to keep my image number because I want to be able to reference that number. And I'm going to type in micrometer, and this was with the 10x objective, and then I have my image number 9963, and I'm going to save it as a TIFF image, which is better than a JPEG, but TIFFs can be opened by most computer programs, so I like to use TIFF in the end. Of course, we haven't tried to enhance this image in any way, which I'll get to later on in the semester. Of course, it's a scientific image, so we need to maintain the integrity of the image and not in any way make this image misleading. So now I'm going to save this image, and I have that reference slide, and now I'm going to do the same thing here. I'm going to go to Save As, and I'm going to keep my number. I'm going to type in muscle and 10x objective with my image number, and I'm going to save that one as well. Now I can close out of Photoshop, and you can see that I have my two images here. I will have this recorded in my notebook as well, but now I've got a micrometer image with the 10x objective at 9963, that's the image number, and then I have my muscle image as well with all of the information built into the title. Of course, if I want to make a scale bar on my 20x or my 40x or 5x or 100x objectives, then I need to take a photograph of the micrometer using those different objectives and use those images to draw the scale bar on images that were collected using the same magnification objective. There you go, pretty simple. Okay, you guys, after you're done, I would like you to first close out of the software package, either Photoshop or EOS Utility or both if they're still open, and then shut down the computer by pressing the power button, and then when this dialog box comes up, click Shut Down. Then we want to turn off the camera and remove our SD card by opening the door and pulling the SD card out and putting this somewhere safe. Please close the door on the camera. Then turn off the power on the microscope. Pull out the micrometer slide and place that back in the slide box. Make sure that you take all of the notes that you need for your images, and finally you can throw away the paper towels and gloves and neaten up the area for the next person, and then remember to wash your hands after the lab's over. That's it, you guys. Thank you. See you next time.